Alright, everyone, please grab the last couple of bites of food, take it with you, or throw them out, and please make your way to seats. There's still at least 20 seats up in the front rows that are vacant. Feel free to grab one. Like that, a nice packed house up front. And we'll begin in just 1 minute. Get those reps while they're good.
Hey guys, thanks for coming to the first meetup of the Los Angeles Big Data User Group. So, just some background. There's a reason, one of the reasons that I have worked with this service group, and one of the things I want to do is bring together all the big data topics. I think there's a lot of information going on there about big data, what big data is, how you can use big data. And I felt Los Angeles didn't have another group to promote this particular arena, this particular into products. So I thought this would be a great opportunity to start the Los Angeles Big Data User Group. So that, it's just to show guys, how many of you know what is big data? Okay, what about data science? What about Hadoop? How many of you have heard about big data? Okay, that's right, that's good. So, anyway, before we get on the topic, just a few announcements. So, we have a number of big data user groups happening all over LA. You notice, there's the extending our language to the enterprise by LA, our user group that's happening on April 1st. If you plan to be in Amsterdam, Europe next week, I'm going to be there. Think about and hang out with me. Some Europe is happening. We have data science at Netflix. That's going to be out here, cross campus, April 9. HP Spawn, which is a NoSQL database that's happening on May 5th. Data science and Activision, the LA Machine Learning Group, again at cross campus on May 28th. Summit in the United States or Santa Clara is happening on June 3rd to 5th. And for those of you who don't know, Big Data Camp LA is open for the second year, which is got confirmation by DirecTV that they will be able to do celebration. Around the next it took a lot of time to go on the station. So we had about 250 people last year, and this year we expect about 350 to 400. Also, it's going to be 3 data tracks, so we'll do big data, Hadoop, and data science. So if you guys want to learn all about what we're going to be talking about essentially earlier, you should attend that particular big data camp. It's a whole day event, 9 to 6. Completely free for the public. You can follow me also on Twitter. And you don't have your Wi-Fi password. It's right there. So with that, let me introduce some of our sponsors for today. For today, I'd like to thank them for coming and helping us to launch this event. So for today, we have 4 of the sponsors: Cross Campus, QConnex, INS, and Nephostat. So they will do a few words of encouragement to talk about what we actually do. So let me first introduce Blair from Cross Campus.
Thanks very much. Hi everybody, I'm Blair. I'm the general manager here. Quick show of hands, how many of you guys have been to this Cross Campus 2.0? Only one, okay. Well, for everyone else, welcome. This is Cross Campus 2.0, the second iteration of our co-working space / work spa. We've only been open here a couple of weeks. And we're still a little rough around the edges, but this is going to be our new space for the next at least 10 years, hopefully. We love doing events here, but we also do, by day, co-working. We have people growing and building their businesses out of this very space. And we love particularly hosting events like big data because we think you guys are doing some of the most interesting, trailblazing, cutting-edge stuff out there in Silicon Beach. We got a lot of big data groups, big data teams in cross-campus, a lot of highly technical people working out of here. So if you'd like to see what it's like to work out of here by day, feel free to grab me or any staff member. We'd be happy to extend you a day pass, and you can see what it's like to work in a place that's hopefully both inspirational and really practical. So with that, I'll give it back to the MC. Thanks very much. Have a great night.
Two things within the common group was not computers.
Hey everybody, my name is Subash. I'm with Q. We're an IT and digital talent firm specializing in LA. We work in LA only. We're very boutique shop. Too many questions regarding the market, need resume help, or looking for a job, or looking to hire people, let us know. The ladies in the back, we'd love to help you guys out and enjoy the presentation. Thanks.
So with that, let me bring on our first speaker, Dan. So Dan is a data scientist and researcher. I'm going to introduce him. He's going to introduce himself better than I can. So with that, let's bring on Dan.
Okay, I'm all the way up here. Here's pretty spirited headset, so dancing or something. I don't do with hip hop, but so it's great to see you guys all here. For any Meetup, so many people show up first time is great. So I think what that says is big data is pretty hot right now. So I'm anxious to talk to you about it. So let's get started. So I'm going to talk about an introduction to big data. My name is Gutierrez. I am a data scientist, practicing data scientist. My consultancy is Analytic Analytics, based here in Santa Monica. And I specialize in machine learning, data analysis, visualization, and most importantly, data storytelling. That is, I can communicate actionable business intelligence to improve the value of corporate data assets. That's what I like to do. But I have another hat. The other hat I wear is as managing editor for InsideBigData.com. This is a well-known online news source for big data industry. I encourage you all to visit because we have a lot of leading-edge articles every single day about the industry and keep a really tight monitor on the industry. Late last year, the editorial team sat down to plan out our 2014 editorial calendar, which is listed right here. So I think this is a pretty good, pretty representative list of topics for the year that pattern big data in terms of product categories, use case examples, conferences. I got the one in July in the calendar because it matches with the USAR conference that happens at UCLA, so I'm pretty excited about that. So if you want to, see like sort of a pulse of the industry, this is what we have in store for our publication. One thing I've learned being an editor for Inside Big Data is that there's a lot of hype right now in the industry. Okay? I mean, it's like supercharged. You can't pick up a publication without reading something about big data, this and that. But not everybody is excited about the hype. And I can understand that. It's sort of like, it's like supercharged, and sometimes you get really tired of hearing about it. But what it's done actually is it's started some flame wars on LinkedIn. People are basically trying to get a sense for their position in big data. And so there's like flame wars that are just crazy. Like the unicorn flame war. This is like discussions about how or how not to hire data scientists. That's very interesting. Then there's the SAS versus R flame war. And the Python versus R flame war. There is the is data science dead flame war. To start it, I'm going to be dead. So the ethics of big data, that's what people are arguing about. And then the one that I just recently wrote a piece about is a flame war about, is there a difference between big data and small data? Oh, already we're talking big and small. So, I mean, I like to write about stuff like that, controversial things. So, I'm sort of like knee deep in all this right now. Okay, so let's talk about what distinguishes or characterizes big data in the first place. It's pretty much the volume of data that is the reason that big data technologies even exist. So, for example, Facebook, collecting 500 plus terabytes per day. That's pretty incredible. I mean, 10 years ago, you couldn't really conceive of that type of volume of data collection. And as a mathematician, I prefer to not really think in terms of the terabyte, the names for these storage capacities. I think in terms of powers of 10. So a terabyte is 10 to the 12th. That's a big number. The next stage up, which people are starting to talk about, a lot of companies are collecting petabytes of data, 10 to the 15 bytes of volume. And even though it's pretty rare right now, but I'm hearing exabyte storage capacities. So that's 10 to the 18th. So these are huge numbers. And, that's really what big data is all about, is the volume. Unprecedented volume. And here's a good quote from an industry luminary from Google, Eric Schmidt. So, from the dawn of civilization until 2003, humankind generated 5 exabytes a day. Wow. Now we produce 5 exabytes every 2 days, and the pace is accelerating. That's incredible. And I think this is one of the reasons why I feel big data is real. It's not going anywhere. I mean, the companies are not going to suddenly stop collecting all that data. So it's a trend that's going to continue. The first time that I remember seeing big data mentioned in any sort of mainstream press was this issue of The Economist from 2010. And I think that's about right. It usually takes a number of years for technology to graduate from IT press to mainstream press. So if you think about it, Google published a seminal paper on a process called MapReduce in 2004. So like 10 years later, or less than 10 years later, in 2010, you start seeing the concepts of big data being mentioned in the publication like this. So now, 2014, everywhere you look, Wired magazine, Wall Street Journal, LA Times, everybody talks about big data. So it is very hot right now. This is sort of the big data landscape. So here we have all these logos for different companies sort of categorized by technology area. Now, as a big data journalist, I know that that's a fraction of the actual companies that are involved. In fact, I'm surprised. Every week, I'm contacted by a new company, or a couple of new companies I've never heard of. There's a lot of startups, a lot of companies are pivoting into big data, and I mean, it keeps me pretty busy writing about this stuff because of all these new releases and exciting announcements and so forth. But I mean, I think this is a sign of a healthy industry when the vendor ecosystem has so many members, and when it has the amount of venture capital flowing into it. That's another sign, I think, of health. And the frequency of product life cycle is also another sign. But like, just to give you an example, like Cloudera just last week announced a new 160 million round of funding. So now they're up to 300 million of funding. Cloudera is one of the three main Hadoop distributions, so it's like a really main industry player. But I mean, I think that all indicates a healthy industry, which is a good thing for everybody involved. So let's talk about a definition. What is big data? Okay, there's many definitions of big data. I think this is a good. There's one example. Big data signifies large data sets so big that commonly used software tools are unable to capture, curate, manage, and process the data within a tolerable elapsed time. Okay, that's sort of why Hadoop exists right now. So Hadoop is a dominant player in the big data market. It's used widely by many of the largest companies, including websites like Facebook, eBay, Amazon, Yahoo. In fact, it was invented by some Yahoo developers. And now it's moving into the enterprise. So enterprise being, ordinary businesses. They have all this big data to process. So Hadoop is now becoming more commonplace there. But this is an interesting graph here because it forecasts the big data market all the way going up to 2017. More than $53 billion market. So this grill is getting really big. It's good for all of us. And this slide sort of summarizes big data. I mean, what it is. We talked about volume. There's more than volume. There's velocity, the speed at which data is collected, variety, how many types of data sets are being collected. There's actually others. There's like veracity, and people keep adding V's. Volatility, validity. I mean, every time I read an article, there's a new V. Okay, so it's a real happening industry, and it's evolving very quickly. Some more characteristics of big data. Okay. Big data is facilitated by data science, which is in itself a new term. I happen to be delighted by that new term. I like it rather than mathematical statistics or computer science. But data science is really very indicative of what I do every day. Data science, in turn, is facilitated by machine learning. It's called data mining. I think machine learning is kind of a little cooler, so I'll go with that. And machine learning is a confluence of disciplines: computer science, mathematical statistics, probability theory, visualization, and many more. But these are tried and proven technologies, so there's really nothing new, but it's being collected and grouped together and applied differently because of the big data aspect. So really the big is the new part. But there's also something new related to big data in terms of the fact that traditional data content is now coupled with internal and external sources of unstructured data via social media. So that's really brand new. Because a few years ago, that didn't really exist as a possibility to combine with, let's say, transactional data, order processing, things like that. And plus, there's new forms of analysis of this data, such as sentiment and credibility analysis. These are brand new ways of processing this data. So, with all the hype and sort of the velocity going forward with this industry, the question that you might think, is there a bubble brewing? You think back to 2000, internet bubble event, will it occur again? And my opinion on the matter is, yeah, it may actually happen again, but not because of big data. Big data is real. So it's not real. It's crazy evaluations that you hear. We're companies are getting valued at billions of dollars with no business model, no possibility of revenue, and it's kind of crazy. So I mean, if there's a reason, that's the reason. But it isn't big data. So big data is innocent. Here's some applications for big data. Now, I thought of all these applications, but you could easily double and triple this list. I put healthcare at the top there because I think healthcare is probably the industry that could benefit the most from what big data offers. Unfortunately, healthcare is like the big laggard in terms of adopting big data technology. It's too bad, but I think that's going to change. I think the powers that be in that industry are seeing the power of big data. So I think that's going to change. Now, there's going to be some pushback, in terms of like privacy, personal information. I mean, you read these articles all the time in the newspaper about, credit card breaches and things like that. So I think that if there's anything that might unsettle, the charge board with big data, it might be that kind of pushback with privacy concerns. But I think what big data just has to do is beef up the big data security element, which doesn't get a lot of play these days, but I think it's going to. And once that happens, I think that maybe this kind of thing will be minimized. So the moral of this story tonight is whatever you're thinking, think bigger, because that acceleration of big data forward, especially the volume and velocity, it's not going to stop anytime soon. So if you have that in your mindset and apply it to the technology you're using, your business solutions, I think you can't go wrong. And with that, I thank you. I will put these slides up on SlideShare if you're interested. Thank you very much. Forgot about questions. Are there any questions?
So what is Hadoop?
Well, Hadoop is like a parallel processing system. I mean, if you think of, I mentioned earlier in the slide that Google presented a paper back in 2004 about this MapReduce process. It's a way of processing data in parallel. So Hadoop is sort of like a creation of that vision. So a lot of companies nowadays, they will utilize the Hadoop infrastructure to implement their algorithms to process the data in parallel and basically achieve processing power previously unheard of, like in a single machine, like a mainframe or even a network of sorts. So it uses like just commodity clusters of commodity servers. So it's open source, but there's vendors, several vendors that have these distributions available. I mentioned one. There's like Mapbar, there's Workworks, there's Meetup. So that sort of encompasses a big part of the data industry, but there's a lot of big data problems that really don't have a well-matched solution with MapReduce. So there's other parts of big data that are equally as important. But Hadoop is sort of like the big gorilla. It's a big elephant in the room. That's why the yellow elephant. Yes?
The average big data project that like a data scientist works on, I mean, how much in the life cycle of a project, how much does it end up costing to process big data? Like if you have like one company that's a small company but they have a lot of big data, to actually do that, what would be the average cost if you use it? I mean, you could do it yourself, but like when you're talking about servers and everything.
Right. Yeah, I think gone are the days really where people invested in like physical servers. I mean, a lot of stuff nowadays is done in the cloud.
Right,
So
but that's still a cost. Spinning up all the EC2s or something.
Exactly. But it's a different type of cost because like in the old days where you had a startup and you sort of try to anticipate how much capacity you need for your product or service, and you go out and invest in physical servers and data centers and things like that. Well, you don't have to do that anymore. You just basically invest in what you actually use. That's what you're paying for. So if you have some sort of infinitely scalable solution in the cloud, that's what you're paying for, whatever you use. So think about how easily that is to forecast, in your business model. It's like, you don't have to have this big chunk data center, server. You don't buy stuff anymore. So that's really good.
So if you go off of like questions, so like in data science, I'm always thinking like, okay, what is the question we're trying to answer with this
Right.
data? And then try to extrapolate, well, what would be the cost of me answering?
You have to do modeling. You have to model, at a very low level, and then you extrapolate. I mean, that's pretty, prediction like that, that's what a data scientist should be able to tell you. So,
Right.
So anybody that's worked with data for a while knows the most fun moment comes when something you weren't looking for comes out of a structured observation.
Absolutely.
But to get to that point, you need a set of tools that let you explore your data set in a variety of ways so you can see it. And I used to say to people, they'd say, well, what are you going to find with that kind of data? Or what are you about to find? I said, I don't know yet, but I know where I will find it. It's in that data.
Yeah.
That's where the interesting thing is, but I can't tell you yet. When you're having to make the argument to business people about what, or venture capitalists, for example, about what you're going to find there, and the answer is not sure yet. Google knows our priority. They just want the data. Not everybody does. So for these mid-level enterprises, how much effort is it just to get to the point where you can explore your own data? Like when I was reading up on Hadoop, a lot of it's just about how you're handling these big blobs of data, and a little bit of it is how HBase is letting you look into structured versus unstructured data. So how close are we to mid-level enterprises being able to do data discovery using these tools?
Right. Well, you still need a data scientist for that. I mean, because
Well, but is
like
the data scientist the guy who's basically spending most of his time managing the data, or is he the guy who's exploring the data and the management side of it is nailed?
I think both. I mean, when I engage with a client, like I have to be concerned about whether they just say, "Hey, you're a data scientist. We got data. Work your miracles." I mean, that's a recipe for disaster. They have to have sort of like an idea of the business problem they want to solve, and then work backwards, see where the data is, and is there
Is that question answered?
are there data sets that can answer that problem? And I think a data scientist is the one to answer that, because maybe, C-level executive might not have that vision, visibility, maybe even their, CTO might not have. But working with those people, see, I gotta work with a lot of different levels in different companies, a lot of different departments.
Let's say you're the guy who's exploring the data itself. How much of a support team do you need around you just to feed you data in a form you can use?
It's important to have the right people, not only feeding you the data. I mean, some ETL engineer can give you a data set, but then I might not have any idea what it is, because maybe I'm not a domain expert in that industry. So the company has to make people available to you, whether they're in marketing or sales or finance or what have you. And then they can tell me what this data needs, and I can go back and say, I mean, what you were talking about earlier is called unsupervised machine learning. Is where, you're not doing prediction, you're not doing classification, what you're doing is discovery, okay? And through techniques like clustering, you can figure some amazing.
So, we all have further questions to you then. So we can talk, so let's do it.
Are any corrections allowed?
But that
Are any corrections allowed?
direction for that.
So that gentleman just asked you about the hardware investments in the Hadoop cluster, and you recommended him to go to cloud, but absolutely no industries are allowed to go to cloud. That's why there are private clouds and semi-private clouds.
Absolutely. There's many different types of clouds.
That's exactly correct.
Okay, there's many different types of clouds, absolutely. But data centers, maybe not so much.
So now we're going to have Szilard come and talk about introduction to data science. Then I'll hand it over to him.
Hi everyone. So I will give a quick intro on data science. My name is Szilard. Here's a quick intro about me. I started with physics about 20 years ago, which was a good place to work with data, do data mining, visualization, and even some modeling. Then I did my PhD applying these methods into financial markets. And I also worked in the financial industry for a couple of years. And then more by luck than by design, I moved out of the financial industry about a year before the financial crisis started. And I moved here to California to work for an e-commerce company. I'm still there. So I do right now a lot of machine learning, data visualization, data mining, data exploration, something that in the last couple of years has been called data science, but this is not really new. So a lot of us have been doing that for a decade or more, just under some other names like data mining. But as Daniel said, I also like data science. It's a better name than, let's say, statistics or data mining. I'm also involved in most of the data science meetups here in LA. I started the R meetup 5 years ago. I started data visualization and data science meetup recently, and I'm also organizer in this big data meetup. So one disclaimer, I'm chief data scientist for Apple. Apple is a credit card processor, but everything here is my own. In fact, everything Apple does is proprietary, so I'm not even allowed to talk about that. So this will be a kind of high-level introduction to data science. So if you're a data scientist, how many of you would say that you're a data scientist? All right, so I don't think I will tell you anything new now, but we'll have lots of other exciting talks that we're gonna go deeper into what we are doing. As for myself, I do everything from high-level strategic advice to CEO to something like more mid-level that would be the full-stack data analysis that Daniel was talking about, and I even develop and analytical systems, and I even involved in operations. So what is data science, and what is it involved in doing data science? I have here a slide that I think summarizes all. I used this slide a few weeks ago for another talk, but I think I found a universal slide that's good for any data science talk. So all you need is this slide. I can talk about this right now for like 15 minutes. I also can talk about it for hours, and I could even make a data science course or a full semester course. So this, I think, it's the best high-level overview of what data science is. And I even have actually this slide of my business plan. So how cool is that? So what is this? So we have data. We want to understand, as Daniel said, what the business is doing. We collect all this data. Then we start exploring it. And exploring means also a lot of visualization, because this is how you can find outliers and you can see what's going on in the data. Then what we do is we clean the data. Most data have a lot of errors in it. And we also transform it. We build features for machine learning. So this means transformations, like, let's say you have clickstream, and then you compute something like, for this user, how many times he clicked in the last hour, in the last 5 hours, this kind of features. And then we feed all this into some model. So this is what the media thinks sexy, the machine learning part. Right? We feed here the models, and then then we check out how good these models are. We validate them. So we must do that. And then if something good comes out, then we can deploy the model, or maybe some wisdom comes out from our analysis, and then we communicate it to management, and it goes back here into we get more understanding about our processes from the data. So this is not really linear. So in every step, you might need to go back to a previous step. I had here a few arrows, but actually from any of these steps, you might need to go back. So for instance, you might see that the model is not working, then you might need to go back, do more exploration, and find more errors, and then make new features and so forth. So it's a pretty iterative process. Also, like the media and the buzz focuses here on the machine learning part, but as a data scientist, I think everyone here would agree that we spend most of our time, probably like 70–80% here exploring the data, visualizing, and being transforming. So how many of you guys are following Big Data Borat on Twitter? Okay, cool. So for all the rest, Big Data Borat says that we data scientists, we spend 80% of our time complaining about the need to, I'm screwing it up. So we spend 80% of the time cleaning the data and 20% of the time complaining about cleaning the data. So many of you guys will recognize that this is what you've been doing as a data scientist or data analyst for long. So the data science name is kind of new, as Daniel's showed it. It became mainstream in 2010, and it became used a few years before that. But most of this is like decades old. So before data science, it was called data mining, and actually this whole process shown here is my interpretation of something that's called Criff's data mining process. That was created by some industry people working in data mining in the 1999, and they created the documentation and also like a graphics that looks pretty familiar, like pretty much similar to this. So a lot of this is been old, and there is also this buzz. And also it's true that now more and more companies have data, and they started looking into data, and it's feeding all this buzz. And also the other thing is that many companies have large data sets, right? So that's fueling the big data part. So if you are speaking of big data, the process of analyzing big data remains kind of the same, but in some parts you need different tools, because some of the tools we've been using, they are really geared towards small data sets. So especially on this part, you need to have other tools. So what's the goal if you are a data scientist in a company? So most likely your goal is to provide business value. So you have to look at it from the business point of view. You have to understand here what the business is doing, and you have to provide models that will be useful for the business, right? So I think so the output of your work is usually an operational model. Let's say you feel like machine learning or scoring something that will separate fraud from non-fraud, or it will have increased sales, or it will be like a recommendation. And then you deploy that, and that can be used for operational decisions, or you can have some kind of strategic advice to the management, like do A versus do B, and you look at the data and you can tell them that A is a much better option than B. So I think it would be a lot of time to go over these steps. So I had a talk at General Assembly a few months ago where I spent about 3 hours going into details, and I still think that I just scratched the surface. So if you're a data science practitioner, then you will spend most of your time doing this. And like I said, like 80% of the time goes here. So if someone was asking about cost. So, yeah. And we spend the time here not because we want to do that, because this is the most tedious part to do, but it's hard to automate that. So the other parts is like easier to automate. So we might find another time when I can go into more details. So Subash mentioned Big Data Camp. I might give a tutorial on data science going through these steps. So that's just a plug to Big Data Camp that Subash is organizing, and some of us are involved as well. Another interesting thing would be to talk about tools that are used in data science. Like, what tools are we using here? So I'm planning at one of the further meetups to have some kind of survey, to survey you and to have like a discussion of what are you guys using, trying also to avoid to instigate a new flame war between R and Python here or something like that. And I would be curious of what are the typical stacks of people, what are they using, for instance, R, Python. I think you kind of need to use SQL or some Hadoop version of SQL like Hive, Impala, or Char. You probably need to use some Unix shell scripting or something like that. So those are all good tools. And then maybe some people are using Excel for some of this, or God forbid, some business intelligence tool. And there is a lot of commercial products as well here. So, and ultimately, I would encourage you all to get involved into this. So, all this. So, at the data science meetup, I will have companies talking about how they put together all these tools and how they put together all these techniques and knowledge into what they are doing. And then I'm pretty sure we'll have here at the Big Data Meetup a lot of folks talking about what kind of tools they are using for the big data parts. We have several other meetups, like the R meetup, which we are talking basically about how we are using that one tool. So I would encourage you to talk to either me, Subash, or any of the other organizers. We all work together, so we'll channel you to the meetup that fits the best your topic. So finally, feel free to contact me. Here's email, Twitter, and LinkedIn. And you can also grab me after this talk. So thank you so much. And if you guys have any questions, I think I have time for one or two. Yes?
So I thought it was interesting when you talked about requires different tools and that level. Like I do some R, and I can do some things in R, but I can't kind of make the connection in my head. What do you have to do when you get really big data? How's that?
Yeah, something that Daniel also touched, and here it was also a question about if you are small, then you have to do everything yourself. So you might need to manage a Hadoop cluster that's doing the data collection, and you might need to write like big or high jobs that do the data transformation. On a larger scale, usually there is a separation between data engineers that kind of manage pipelines, and then data scientists that do the exploration and maybe the modeling. And but they also have to work together. For instance, it's usually the data scientist who is doing the model, who knows better how to transform the data. And we also need to work together with, as Daniel mentioned, marketing and all the other parts of the company to get a business understanding, to make sense of what to put here in the features, right? So how to transform the data. So I think it's breaking down mostly into data engineers and data scientists, and then but they all work together and they work together with the rest of the company. And it's very important for management to get involved and have like a push for everyone to work together and make things happen. Yeah, any other question? Yes?
At the inquiry stage, is it really big data there, or are you taking subsets to play around with, and it doesn't become big data again until you scale it back up and you've created the model?
Yeah, I think it depends on what you're doing, but yeah, in most projects you can start maybe with small. In a setup where like it kind of depends also on the like signal and the noise ratio. If you have enough signal for like a small sample, then you don't need to go big. You can grab that and then you can test it with and build like a smaller scale machine learning. And you can also what you can do. You can also aggregate a lot. So you can go from having your big data and Hadoop here to make groups and aggregates in some form and featureize them here, and then here it will be a smaller scale. Yes?
What would be an example of one of the most interesting things that you've discovered or seen discovered using this pipeline? So trying to understand some data and then something you actually came to understand from.
Yeah, I think all of this is exciting. As I said, I preach companies to come here and talk about what they're doing, but I'm not allowed to talk about what my company is doing. But a lot of times it's kind of exciting to kind of go out of your way and build some visualization that it's very simple. It's nothing related to like sophisticated sexy models, but it's so useful that the managers love it and they love to watch it every hour or something like that. So, yes.
So what is a data engineer?
So I think that data engineering role is more like a developer and operational. So if you combine it to a DevOps, if you subscribe to that movement role, that it's managing more like the IT and data infrastructure. So developing, so it's kind of like, it could be like from the database part, but also from they're managing the ETL part, which, right, this part and then transforming the data. I think Subash can tell you a little bit more because his role is closer to that. Yes, any other question? Last one?
What tools do you use for visualization except R? What else is there for visualizing?
Yeah, I tend to use mostly R. I think if R didn't exist, I would use Python, so I don't subscribe to the frameworks. I think you can use R and Python together. I'm happen to run a data visualization meetup that I started a few months ago, and we kind of interviewed people there, and the biggest group is they're using R. There is the next group that's mostly developers who develop visualization tools, and they use JavaScript because now everything is on the web. And the third biggest group is users of Tableau, so I guess they are more like data analysts, business analyst types. I think Tableau is the biggest in the area of those folks who are coming to meetups. All right. So I think we're good for now, and then we can have more questions after all this. And also, like, once we finish, you can just grab me if you have any more questions there. So thank you so much.
Hi guys. So I'm going to talk about just a brief introduction for you. Just a quick show of hands. How many of you have heard about it? All of this is good. So, I mean, I'm going to talk to you about what Hadoop is, what it isn't, and, you know, bring this into fallacies and myths about Hadoop. So, this is myths. Oh, one is presented. So who am I? So I'm done a bunch of things in the champion of Gutierrez, Florida. I ran a bunch of video user groups. I spoke at some of the Hadoop summits out in San Diego and we had Hadoop Summit Europe. So anyways, coming back to that, what is the big data? I'm sure Brandon talked to you a lot about this, but to me it's always, how much data do you have? At a minimum, I'm looking at terabytes, petabytes of data for big data. The enterprises are generating huge amounts of data. Every time you travel by plane, there's so much information gathered. A lot of people have heard about the plane crash, Malaysia Airlines, and the amount of data that is collected by those engines are flying. It's sad to happen there. Those engines, as Rolls-Royce engines that fly, they were transferring data every 3 to 5 minutes to the headquarters in London. And imagine there's probably 1,000, 2,000 planes out there transferring information. That's a ton of information that's coming in just from each plane out there. Imagine you have 4 engines, each engine transmitting so much amount of data, and all that going back to the main crashing point, whether you sift through the data and make some kind of analysis of it. But that's just a huge amount of information that's coming in. And airline collects 10 terabytes of sensor data for every 30 minutes of flying time. That's just one airline. Imagine how many jets are there in the world. New York Stock Exchange generates 1 terabyte of new trade data per day to perform stock trading analytics. This is a little bit older slide, probably about 2011, but I just want to bring it back to what Facebook is doing. Facebook is one of the biggest consumers or users of Hadoop on the planet. Record breaking 750 million photos uploaded. This is 2011. And you extrapolate to 2014, we're looking about maybe 3 to 4 billion photos easy. 206.2 million internet users in the US. It's probably going to probably 4 times. 20 minutes on Facebook was 1 million, link share, 1.4 million events, event rights, 2.7 million messages sent. But think about it, in 2011 this is all happening. In 2007, how much more data has been collected? Twitter too, Twitter has about 500 million registered users, out of which USA has about 142 million users at there itself. But the amount of information that's generated per Twitter, look at that screen out there, look at the everyday refresh itself. There's one tweet that's generated every second or every less than a second. And the amount of information that's generated is that you have to make sense and analyze and use that. Think about this, if you were to combine your Twitter data, your Facebook data, your Google data, what could happen? Biggest privacy problem in the entire planet, right? I don't want to be open the doors against all these companies out there. But if you think about that, imagine if you go watch a movie today. You post it on Facebook, I say, I watched this particular movie. You have 10 friends on Facebook who then tweet out or tweet or say that, okay, that this movie is pretty good, I want to go watch it. And they tweet it out to their friends. And imagine that it's like a social awareness that everyone out there on your network is kind of influenced by this. It's free marketing for movie. At the same time, it's also kind of like a market gathering information for the companies out there. It tells them that there's people out there willing to watch this movie. There's someone out there who's willing to spend a few dollars investing my movie to go and watch it. So it makes sense for them to go and push the movie awareness out there. Get more and more people involved into that. So Dan, he kind of pointed out these 3 definitions of big data: volume, velocity, and variety. I don't want to go into it. But one of the things that I was out there, in 2011 there was about 1.8 zettabytes of information. Zettabyte is, I think, 10 to the power 21. That's a lot of information out there. In 2015, we're looking at 7.9. So that's about a 5-fold growth or a 4-fold growth in just 4 years. Unstructured data is exploding. That's what's happening. So the amount of data that's being generated, you have Twitter, you have Facebook, you have Google, you have Foursquare, LinkedIn. The problem is all of them are generating data in their own formats, right? No one is going to come to everyone wants to do it their way. You have party A, party B, party C, everyone generates. And all this data is coming out, it's structured, but structured only for that company. But if you want to combine the data across 4 or 5 different platforms, that's a huge problem. In essence, it's still kind of unstructured because you don't really know how the data interacts with each other. You could be on Google, you could be on Facebook. The relationship between the 2 of you, you guys may know each other very well. Your degree is sufficient to be one. But the problem with the fact is that because the data is being generated in 2 different ways, there's no way to connect the 2 of you. And that's what's happening here. The relation data is, growing in a sequential rate. There's no change in that. But the complex unstructured data has tremendously increased. The problem being that it's unstructured, you have no idea how the data looks like or how it feels. And that's when Dan and Szilard said, the dispense to 80% time exploring the data and cleaning out. It's because the data that's come, it's complex and unstructured. And just to give you an example, a lot of data you end up throwing out because you really don't need it, at least at this point of time. So that's where this kind of thing that's coming into place, it's looking at. So, common big data customer scenarios in the financial services, scenarios modeling include risk, threat analysis, fraud detection, trade surveillance, scoring analysis. How many of you have a Chase credit card away? Okay, how many of you have actually got a fraud alert from Chase? See, your credit card has been, this fraud. I have. And guess what? I don't think I'm going to do. Chase was one of the earlier users of adopters of Hadoop. Back in 2010, 2011, they were already able to do. How many of you guys are using American Express credit cards? These two are big adopters of Hadoop. if you can imagine, a lot of this is going on right now. They actually have a fraud detection system every, so 5 or 10, 15 minutes goes and sifts through the data, kind of comes up with analysis and sees, does this charge or is this particular event that's happened, is that a fraud event or is that an actual event done by the consumer? We have been detailing recommendation engines, ad targeting, search quality, using click fraud detection. So I go from the advertising industry, online advertising industry. That's how I learned Hadoop. The online advertising industry generates the most amount of data so far as I've seen. That's why Google and Yahoo developed Hadoop in the first place, because they were generating so much amount of data that they needed some way to consume it. So when I was in this industry, I saw the problems with it. Because we were running on an RDBMS, MySQL, with Perl, and we were running into huge problems in storing the data. We just couldn't store the data. We ended up throwing away a lot of data because we couldn't store it. So when I started looking, what's the next technology out there, I started wondering, why am I spending 60 to 70% of my time actually maintaining servers? I wasn't developing code, I was maintaining servers. So 60 to 70% time of that was doing that. So I wanted to find something that would enable me to spend more time developing code rather than focusing on servers. And that's when I looked at Hadoop and saw this is clearly an advertising industry, problems to solve. And the fact of the matter is, a lot of the early adopters of Hadoop was an advertising industry. So retail, point of sale, transaction analysis, customer churn analysis, sentiment analysis. Other industries, telecommunication, customer churn prevention, network performance optimization, call detail, record analysis, analyzing network to predict failure, fraud detection, cybersecurity, and finally ETL and process engineering. So what are the things you get out of your big data? Insight into data can provide business advantage. Some key early indicators can be fortunes to business. More precise analysis and with more data. So just as a corollary to that, last year there was a very good Ken Rubin, director of analytics at Facebook. He came up with this precise phrase or something that I think kind of makes sense. He said that big data comes big impact. And if there is no impact, then you have done nothing. That's, to me, that was key, because then to me, I realized that, all the work that you spend in doing this, trying to, you could say big data, you could Hadoop, you could put this, but at the end of the day, if you don't make changes to the bottom line, if you don't increase your revenue, if you don't, in some way make some kind of analysis or insight of it, that makes a change in the company, you have done nothing. All your spend is, millions of dollars, $100,000 into $100,000, that does nothing. You might as well give me your money, and I'll go spend it, right? Why spend it on that? So that to me makes any sense of that. With big data comes big impact, and if you have no impact, then you have done nothing. So what big companies have to say? Analyzing big data sets will become a key basis of competition. Leaders in every sector will have to grapple the implication of big data. McKinsey is one of the big institutions out there. They pretty much, at least for enterprise companies, they pretty much define that some of the reports that they come out with, if they do say that big data are two of the key indicators of leading technologies that can be used to process big data, a lot of companies do follow them. Similarly with Gartner and Forrester Research, these are companies that they don't bullshit about because people pay them for the research. So they have to be sure what they say. So, Gartner says big data analytics are rapidly emerging as a default solution to business and technology considered in this topic. Forrester says prioritize big data projects that might benefit from Hadoop. So, to just give an example of why big data came into place in the first place and why it came into a picture. Limitations of existing data analytics architecture. So, the bottom layer of the collection and instrumentation where the storage only get original raw data. You're moving data into the compute doesn't scale because when you're exploring original high fidelity raw data, you're storing that currently into something like an RDBMS typically, right? Most people put in a SQL Server, Oracle, MySQL, Postgres or something. The problem is that the more and more data that you get, there's only so much capacity that your RDBMS could handle. At some point, it's going to it's going to taper out, or it's going to be slow, or it's going to cause problems. That's what happens with this particular problem for you. Moving data to compute doesn't scale. So, we'll talk about this a little later, but there are different ranges of where big data makes sense and it doesn't. And I'll give you an example of what I think it is, some of you might find it different, but that's my analysis of it. So the third thing is archiving premature data debt. So a lot of it is also the problem that you have to do your own archiving of the data. And if you don't do it, if somebody in data fails during archiving, you can pretty much lost the data. And in collection instrumentation is mostly archived because the data you probably limit every 5 minutes or 10 minutes, and then you have the data so on and so forth. So what is the solution? Combined storage, compute layer. So everything in this, you said storage will be great, archival, and I can't explore original high fidelity raw data. If you replace the whole thing with just the Hadoop layer, the storage and compute layer, we pretty much solved most of the problems we had. For scalability, to actually scale the data to petabytes of data, it's proven, it's built out there. All the major companies out there using it. The other thing is your archival or your data storage. Hadoop gives you by default 3 copies of the data, so it will automatically redundantly copy the data 3 times. You can change the data up and down based on what you do. By default, gives you 3 copies of data. So that means that for all the data to be lost, probably means at the minimum the 3 servers where your data is stored for it to be grown at the same time. It's possible but unlikely. And for you to lose all of the data completely, and then Hadoop cluster out of the world. The third thing over here, compute grade can actually run MapReduce. Not talk about MapReduce a little bit. That will actually process the data and give you the output very well. So differentiating factors, accessible, simple, robust, and scalable. Some of the other users out there, Yahoo, IBM, Rackspace, Amazon, eBay, Morgan Stanley, Google, Facebook, LinkedIn, and the symbol for Hadoop is the elephant. Anyone knows what how the name came about? So the founder of Hadoop, Gutierrez, his son had an elephant dog. So actually called Hadoop, but he was looking for the name at that time, and he heard about it, so he found it to be interesting name. So he named it Hadoop. So and because the name of the elephant dog, it kind of became that thing. So the symbol for Hadoop is one elephant. Some of the other users in detail, I won't go into this into detail, but you have fully posted slides of data in detail. But AOL, eBay, Facebook. Facebook is one of the biggest consumers of Hadoop. And if you might, I don't know how many of you actually use a Facebook messaging platform? So the entire messaging platform is built on top of HBase, which is built on top of Hadoop. So it'd be good to know that it's good to know that you're actually using Hadoop in live when you use a Facebook messaging platform. In fact, Facebook is migrating a lot of their, all the reporting systems. Reporting sense, their backend reporting systems, like how the servers are performing and those kind of analytics, and moving into Hadoop so we can get better analysis of how their servers and clusters are performing, and changes the file that it needed. So other users, LinkedIn, OpenStack, Rackspace. So when it came to Hadoop, in traditional large-scale systems, the computation has been processor bound. So a lot of time, for the past 20 years or 15 years, the talk has always been CPU. Let's try to increase the CPU. Let's try to increase the RAM. That's how we can scale. That's how we can perform better, process the data better. But if you think about it, buying more CPU, buying more RAM does not necessarily give you, the capability to power to process all the data. Because at some point in time, you're going to have more data than what your CPU can do. Then that just means, spending more money to get the new best thing out there. It's just a never-ending cycle. So relatively small amounts of data, significant amount of complex processing performed on the data. But I guess primary push was to increase the computing power of a single machine. Faster processor, more RAM. Motivation for Hadoop, problems with traditional large-scale systems and requirements for a new approach. In distributed systems, even familiar distributed systems? So, Moore's law roughly states that processing power doubles every 2 years. Even that hasn't always proven adequate for very CPU-intensive jobs. Distributed systems allow developers to use multiple machines for a single job. So things like MPI, PVM, Condor, a little bit older technologies that were built just to handle distributed almost a year. Other thing with distributed systems, data storage, typically data for distributed systems stored on the SAN. At compute time, data is copied to the compute nodes, planned for library and module. And that's typically a common problem. Right? If you copy your data from a SAN to a node, and it's a large data set, it's pretty much a lot of time is spending just in the bandwidth IO, transferring data from the SAN into your node, and then processing and then calling the data back out of the SAN. So, this I think is one of the key things out there and why Hadoop kind of makes sense. More data usually beats better algorithms. And to me that made a lot of sense because you think about most algorithms that are built is built around a particular data set. You have a particular data set that's given to you. It may be small, it may be structured, it may be fine, and then you apply algorithms to that. You build up, keep on defining algorithms till the algorithm actually, in some ways processes the data and gives you some kind of valid output. The problem comes is that you then bring all the data in. And not all the data can conform back to your structured data set. So they will become in any way or any form, any format. When that happens, people needs to break algorithm. So to me it means that there's no way for you to envision all the data and how they look and how they structure it. As the data comes in, you have to keep on updating the algorithm to expand. And that's a lot of time I spend is actually expanding the algorithm on there to actually encompass the different kind of data structures that I get. Because I don't know how the data structure looks like. I mean, typically when I get web logs and they give me particular structure, but I've seen times when, for example, someone does a SQL injection that breaks my algorithm, or someone does something from PPA and that so on, and that puts an extra semicolon or does something, and then that breaks our algorithm. These are things that you don't actually, you can't envision all the proper and envision all the edge cases. As they come in, you build your algorithm from there. So to me, that's kind of the key thing over here. More data usually beats better algorithms, such as recommending movies and music based on past preferences. So how finished algorithms are, often they can be simply be by putting more data in place. So what is Hadoop? It is based on work done by Google in the late 90s, early 2000s. Specifically, papers describing the Google file system in 2003 and Gutierrez in 2004. This work takes a radical new approach to problem-distributed computing, meets all the requirements we have for reliability and scalability. Core concept: distribute the data as it is initially stored in the system. Individual nodes can work on the data local to those nodes. No data transfer to the network is required for initial processing. So one of the key things over here is all of the data actually resides in the nodes. When you start processing the data is actually processed on the node with the data. So you don't need to copy the data from a third node or fourth node and bring it back to another node and then start processing. It's already available there, readily available for processing. Four other concepts written in high-level code, nodes talk to each other as little as possible. What we call the shared network architecture. Data is spread among machines at once. Computation happens where the data is stored wherever possible. Data is replicated in multiple types. So this is what talking about the default three levels of the redundancy or application. So this is just what Hadoop is all about. That's why we give a brief overview of what it is. So in context, find me on Twitter. I tweet a lot about Hadoop and Hadoop-related topics. And if you follow me, you pretty much find about it. Also on LinkedIn. And I just want to mention, so Hadoop is not a magic wand. A lot of people think, Hadoop can solve all your problems. It is definitely not that. Hadoop is not real time. It's a batch-oriented processing system. Don't expect it to track a query and expect real-time response. It takes time to compile. It's probably like 5 minutes, 10 minutes, 15 minutes. Sometimes it takes an hour, depending on the size of the data, to actually come back. So one of the vulnerabilities of those people think Hadoop can solve everything, no, it cannot. And I initially told you that there are different data ranges which I look at. So let's say Hadoop falls good in the data range of hundreds of gigabytes to petabytes. So if you have something less than 100 gigabytes, I would say go with an RDB is something Postgres and SQL. So those can handle pretty well. You don't need to go Hadoop. It's not meant for those cases. Between 100 gigabytes and 5 terabytes, I think is the borderline place for Hadoop. 5 terabytes onwards is very good use case for you. The other thing about Hadoop, as Dan mentioned, security. Currently, Hadoop, there's a lot of things being worked on because it's an open source project. There's a lot of work being done on security right now. So a lot of because one of the enterprises are requiring that they want security as part of their initiative. There is work being currently going on to make it more secure. That being said, it's work going on. It's not happening. So there are workarounds to this and how to make it structure secure, but there's not enough person taking production area. At some point of time, there will be more security in Hadoop. At the current point of time, it depends on how you secure your cluster. So questions?
You said that there's about like 1 zettabyte of big data, and I was just curious, how much of that is open data that's you can scrape online and with different tools versus being siloed? And you were saying there's security holes in Hadoop, so you can't. I mean, you possibly could get certain data that you want, but certain data you can't. But I was just curious, what percentage of that zettabyte is actually accessible?
So. Good question, because I've been actually looking for public data sets. There are 2 public data sets that are currently going on. So Amazon has a public data set cloud. You can just type in Amazon public data sets, and a lot of the companies are actually pumping the data to Amazon, and you can actually go and pull out the data and create it. That being said, it's a little bit old. It's not current, it's not fresh. Twitter has stopped giving firehouses. Twitter is allowing you to download the data before. Now you can't do that. You need to be an academic institution and actually submit a valid request to put the data. Otherwise, if you want all of the data, otherwise you can put individual streams of data. If you know the user or the actually put the user streams, but that doesn't mean get all the data. If you want, like data for the entire month, that you have to actually make a use case for that. And I think one of the reasons I think with that is the resources, because that just means a lot of data that someone has to do it. The other thing is cities, and I don't know, has anyone been to the Hack for LA or the Open City Initiative? Yeah, so a lot of the cities, LA also being part of the actually open source data. That means that the data is not a lot, it's small data. But it's still open data out there. One of the other things I look at big data is not the fact how much data you have. I look at the combinatorial explosion problem. And what I mean by that is, imagine you have, let's say you have 10 different data sets, each of them is probably about also let's say 50 gigabytes each. But your combinatorial explosion problem comes from combining data set A times B times C times D, and in the end what we have is a giant blob of huge information data. There's actually a big data problem there. So that time can actually call it a big data problem. So for me what I see is that in both of all these studies opening up the data, if we can combine the data and actually use other city data to make an analysis on what, say, Los Angeles does for reason, we can actually come up with an analysis of what's happening. So that's probably a good use case for you right there. So that's an open city initiative. For the company which is doing it, but if you search for open cities, you should probably able to find it.
With the open data, Meetup is
Okay, so Mari is only co-organizers. We just got some open data to be doing something. Cool. Any questions? Sorry, I didn't hear you. Yeah, Sequoia, exactly. Yeah, that's the one. So Sequoia is a company that allows you to do they actually sponsor the data pipeline between the different cities, and they allow cities to open up the data on them. So Sequoia is the one that does it. Any other questions? So, good question. So, it depends on the multiple ways of doing it. So, there is Hadoop tools out there, tools like Flume and Pafka that allow you to bring the data from web servers or some location. Also, then you can even manually put the data in. You can just copy the data within iSync or CP, copy the files over to your Hadoop server and then push it into HDFS. When people talk about Hadoop, there's actually two technologies. It's HDFS and MapReduce. HDFS stands for Hadoop Distributed File System, which is underlying file storage for Hadoop. And MapReduce is the technology that actually processes the data. So HDFS is based on GFS and MapReduce is based on MapReduce. And just to give you understand what MapReduce is, it's kind of like, we take a job, we split it up into multiple parts, and we bring it back together. So a good example would be like, paper distribution company. When the paper distribution company has to send the papers out, they probably have drivers for each region. So what they do, each region is targeted to that specific region. They don't talk to each other region, they don't go over each other regions now. They specific, they are targeted towards the region, they focus only on the region. So what you think about is a paper company splitting all the papers into multiple portions, giving that to any specific driver. So that's a map. So every driver becomes a map. And then those drivers, they go there, put the data, papers in the specific locations reduce. Because they bring the data and putting it into specific locations on their data route. So they're reducing the data. That's kind of a map-based analogy of it's just a simple sense of how to explain it.
So my question is in kind of similar vein. So somebody who has, I know Hadoop exists and that's about it. I know a bit more now. Are you aware of any really good resources for people who are new to Hadoop and want to learn more about how to actually use it?
Sorry, I didn't catch your question. Could I use?
Do you have any recommendations for people who are new to Hadoop, some good resources?
Yeah, I could put up on the website or the Meetup page information on how to get into Hadoop and learn more about it. For me, one of the big things in Hadoop, and this is kind of the main issues of getting into it, is you need to have a setup for that. So some of the big companies out there, Cloudera, Hortonworks, and Pafka, they actually allow you a virtual machine which you can download on your computer and play with. And to me, even though it doesn't give you the full feel for it, it just allows you to play with it. You can probably copy a few files here and there, but it's a lot of it depends on how much memory you have. And CPU is not so much, but memory is a lot more important. Because you try to run an app page, all you don't have memory, also with a virtual machine, can play it software. It's not it's just allows you to learn from that. So I could give you links to that just for you to play and just get used to it, figure it out. But in terms of actually learning it, the core concepts are important. To me, I always look at the fundamentals of what Hadoop is, why you do things in Hadoop. Because when you start very Hadoop, there are a number of tools that Hadoop provides. Tools like Big, Hive. How many of you are familiar with SQL? Most of you should be. So to make Hadoop easy to the layman, they build this tool called Hive, which is basically a SQL layer and they interface on top of Hadoop. Which still doesn't mean that you're going to get real-time responses. The response will probably going to be like 5 to 10 minutes or even hours. But allows you to type in SQL query and get responses back. So Pig is another, I would say, a scripting language that is built on top of Hadoop. It's written in Pig Latin. That's also a way of processing data that we have. The tools like Flume, which allow you to ingest data. Tools like Scoop, which allow you to interact with the database. So with SQL Server or Oracle, you can pull and push data from both ways. And then there's a number of other tools. In fact, just to give you an understanding, every 2 weeks, literally every 2 weeks, there's a new Hadoop technology tool that's coming out. I can't keep up with it. I'm in this space for 3 years. I literally have found it difficult. But that gives you, it also shows you the pace of innovation that's going on and how much, there's, work is going on there. So people are adopted this really huge. There's a huge amount of work going on, a huge amount of interest going on there.
What newer technologies are on your short list that you haven't gotten to learn or to look into that would help aid you in the stuff that you're doing?
So, there's a lot of interesting things coming out. To me, I think the 2 big things I see right now, which are important to Hadoop, real-time Hadoop and security. So, real-time Hadoop, there's a lot of work going on right now. So, the tools like Impala, the Spark, there is Hive on top of Case, and there's even Critical's Hawk distribution. So, a lot of work has been going on to make Hadoop real-time. That being said, it's still not as real time as you want. There's still some delay. It depends on that, but some queries return much faster than others. Some still take that. But there's a lot of work going on. Second thing is security is still a lot of work in the making. There are workarounds being done around it for now. People haven't asked for it so much, but I've seen a lot more, people or companies asking for security, that they want security models. So things like Cloud Sentry, Project Knox, Kerberos has been there for quite some time. But those are things that are starting to pick up more and more the security problem. And then HBase just came out with their new security version. So HBase is the NoSQL that's built directly on top of Hadoop. In fact, HBase is a tool that you use Facebook messaging platform. They actually use HBase to run. HBase is built on top of Hadoop. So, which is NoSQL database. And because it's built on top of Hadoop, it can scale really well. You just have to throw nodes and it can scale. No problems at all for that. So, they just release security, security level at the cell level. Has anyone heard of Acumo? So it's the NSA database, the database that's used by NSA. That is part of the, so they did the NSA open source Acumo, you can actually go and download it. So HBase and Acumo, they kind of in a similar space, and they kind of do similar things, but the users people taking some of the ideas from Acumo and implementing it. Sorry, can you repeat that question?
Yeah. What's the balance between redundancy and having more computation power?
So to me, I see computation power is not based on the CPU. I see it's more of a function of how many nodes you have. Because you throw in, because it's a MapReduce problem.
Yeah, sure. But my understanding from you is that every node would have to have a whole copy of the data.
Not all parts of our data. Because when you actually store data on every node, you actually store in parts of it. Or sorry, the term for it, but it's a it's data block, a block of data that's stored in every node. So you don't actually have all the data in all the nodes, just small ones or chunks of the data. Any other questions? So I just want to bring up my co-organizers for this meetup, and then we can just so Szilard, Dan, Mari, you come to the stage. So first thing, if you have any questions for any of us, now's the time to ask. Any questions?
Yeah, how aggressively are you going to have meetings and get information out?
So I think it's a function of two things for me. Standing a speaker on innovation. I think I'll probably work with class campus and as well as work with class campus and at time and see what the work is. Speakers on the other hand is a little bit tricky, so you need to figure out which speakers are available. That being said, one was available talk on the topic.
Yeah, I think the button right now is speaker, so if you can speak about something, then let us know, or if you know someone who would suggest that we should contact them, let us know.
No one wants to know anything what we did about it?
So one thing I wanted to let you guys know, there's a lot of different meetups that we've all been participating in. So if you take a look at the machine learning, the data viz, what's the other one? R. Big thing in R over at UCLA in July, so if you want to check that out. There's a lot of Python stuff going on in Python, a lot of Python games, but they won't talk about the data per se. Then you got the HBase, the Hadoop meetups, which Subash has been running. Are you running it? Okay. There's also the open data meetup over in London. So if you want to get into the open data set, there's a lot of great stuff happening. At Scale, we did 4 sessions. We were talking about big data. We were doing a big data camp June 14th. Over at Direct Eats, we'll have 3 to 4 classrooms going on concurrently the whole day. And so there's a lot of great potential here. But again, so if you do know people who like to present, let us know. And some of these years sometimes get booked really early. I know while when you're running, you've got some RSVP quick before you run right?
Yeah, as a Google, you need 2 hours in 55 minutes. I don't know. But yeah, for data science meetup, I have plenty of speakers. I have lined up to October, I think, but I'm still looking for speakers. I think many of these meetups will find speakers. But we want more, so I like to have like a minute queue for something like that.
I had a question. When I went to Scale this year, and they had one of the guys who was working with all the data scientists at Facebook, and he gave a presentation about something called Presto, which was the distributed SQL query engine concept. And I was just curious, since you guys are data scientists, very experienced, I was curious what you thought of that particular technology.
So, as some information, so Presto is actually an advanced engine level 5 was meant to make Hive had a lot of problems. You mentioned it's a SQL layer on top of Hadoop, but for all its purposes, it had problems. It couldn't, especially running on large cluster, it couldn't actually put the data back together on stars and response time. So Facebook can upgrade Presto as an advanced version of Hive, and I think what they are trying to do is actually open source Presto. I don't know if open source already, but they want to bring Presto as one of their tools that works like Hive, but best case when I talked to a Facebook guys, they mentioned that this is still a work in progress. They still have, I would say 80% of the jobs are still in Hive. They're slowly trying to migrate things into Presto, but it's still not completely happening.
I think they announced the open source there.
Yeah, I believe so.
Yeah, so it should be open source now. Yeah. I don't know. I was thinking we should see if they want to present over at Big Data Camp. So we'll see if we can get them here. Yeah. So I know I actually was in that session and it was interesting.
Any other questions?
So Subash, we plan on this group meeting how often?
At least once a month, we try to do this at least once a month. Again, it's dependent on speakers and the patient gets stimulated. But as long as we can get speakers, it's once a month. So, quickly, because this is a relatively follow the data topics are there. What's the next topic on here? So, is it Hadoop, NoSQL, data science? What are the topics on here?
Spark? Hadoop?
Hadoop. So, answer Hadoop, how many people are in the course? How many people are doing topic on Hadoop? So, 2, 3, 4, 5, okay. NoSQL? 1, 2, 3, 4, 5, 6, 7, 8, 9. What about data science? So I guess we have NoSQL.
Well, I think we'll just keep throwing stuff in and wrapping around.
Alright, so thank you everyone for coming and thanks to the organizers and class campuses for helping us set this up.
Thank you for setting this up, and within the NoSQL, if you do get someone, I'd be interested to hear about Redshift. That seems to be pretty hot. It seems to have lowered the price across the board, like the processing per terabyte.
Exactly. So the thing with Redshift, it's all Amazon. So if you have a data on Amazon, it
Yeah.
makes sense. If it not on Amazon, doesn't make sense. So
Yeah, I know.